This is question 15 from the GATE 2016 session 2 EC paper, where we are asked to find out which one of the following statements is correct about an AC coupled common emitter amplifier operating in the mid-band region. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. So what I've drawn here is a common emitter amplifier with the AC coupling capacitors. This is the AC source and this is the load resistor. The capacitors drawn in red are parasitic capacitors, and this is the voltage gain of the common emitter amplifier. This region in the middle where it is flat is the mid-band region. So what you can tell about the common emitter amplifier is that it is an inverting amplifier, and what you have here is the CBC capacitor that is connected from VI to Vout. So this is the Vout node, and this is the VI node. So we know that if you have such a setup, then this capacitor can be split as an input and output capacitor as a result of the Miller effect. The input capacitance and the output capacitance have the following expressions. And the idea is that you now have a pole at the input and a pole at the output. Let us see what happens in this region after FH. So over here I have expanded the FH. You can imagine that this is where the midband region ends, and you get the first pole causing it to drop off at minus 20 dB per decade, and then at the second pole you have a further drop at minus 40 dB per decade, right? So the idea is that until the midband region finishes, there is no effect of these poles, which is to say that the capacitor is open. But after the midband region, we see the gain drop off, which is as though there is now a short. Thus, the answer is that the device parasitic capacitance behaves like an open circuit, whereas the coupling and bypass capacitances behave like short circuits.